Good morning, students. Welcome to our online class. Today's topic, electron microscope, from the chapter Dual Nature of Radiation and Matter. Okay, the topic is electron microscope. Electron microscope. Right. First, what is microscope? What is microscope? Anybody can say what is microscope? Students, hello? Students, can you hear my voice? Hi, students. Anyone unmute your audio and tell me what is microscope? Swati. Hello. Monia. Okay, no problem. Hello. Microscope is an instrument or a laboratory instrument to magnify the small objects. Microscope is a laboratory instrument used to magnify the small objects. Right. So there are two types of microscope already discussed in the previous classes. What are the two types of microscope? Simple microscope and compound microscope. Right? The types of microscope are simple microscope simple microscope, and second one is compound microscope. Simple microscope and compound microscope. Right. Simple microscope is also called magnifier. Already you know that. Magnifier. It consists of only one convex lens of a suitable focal length. Okay. Simple microscope is also called a magnifier. It consists of only one convex lens or converging lens or biconvex lens of a suitable focal length. Right. If the object is placed in between principal focus and the optic center of a convex lens in the simple microscope, it produced magnified image. Am I right? In simple microscope, there is only one convex lens. If the object is placed in between principal focus and optic center of a convex lens, the simple microscope will produce a magnified image. Simple microscope will produce magnified image. The magnification that can be obtained from simple microscope is just 20 only. The magnification that can be obtained from simple microscope is just 20 only. That is, simple microscope magnify the small object up to 20 times. Okay, so the maximum magnification that can be obtained from simple microscope is just 21. Right. For getting maximum magnification, a compound microscope is used. So to get magnification more than 20, okay, we can use compound microscope. Right. The compound microscope consists of two lenses. I mean, two convex lenses. Right. One is the objective lens, and the other one is the eyepiece. What is objective lens? The lens which is kept near the object to be magnified is called objective lens. Eyepiece, the lens which is kept near the eye is called eyepiece. So there are two convex lenses are there in compound microscope. One is called the objective lens and another one is the eyepiece. Okay, right. So the maximum magnification or the magnification that can be obtained from compound microscope is (2,000). For best compound microscope, the maximum magnification that can be obtained is 2,000. 2,000. Okay. Simple microscope, the magnification is just 21 days. But for compound microscope or best compound microscope, the magnification that can be obtained is 2,000. That is, a small object can be magnified nearly 2,000 times. Right. So to get the magnification more than 2 lakh times, more than 2 lakhs, compound microscope is used. Sorry, electron microscope is used. Okay. So to get the magnification more than 2 lakhs, electron microscope is used. Okay. So the magnification that can be obtained from simple microscope is 20. For better or best compound microscope, the maximum magnification obtained is 2,000. So to get the magnification M is more than 2 lakh, the electron microscope is used. Electron microscope is used. All right. What is the electron microscope? Electron microscope is a scientific microscope or scientific instrument Electron microscope is a scientific instrument which is used in research laboratory. Electron microscope is a scientific instrument which is mostly used in a research laboratory for the purpose of magnifying small objects. Okay, so what is electron microscope? Electron microscope is a scientific instrument. Okay, used in research laboratory. For what purpose? For magnifying small objects. For magnifying the small objects. Right? You know who is first designed the microscope? I mean, electron microscope. The first electron microscope was designed by Russia. Okay, right. So to get the magnification more than 2 lakh times, we can use electron microscope. Electron microscope is a scientific instrument which is used in a research laboratory for the purpose of magnifying the small object. For the purpose of magnifying the small objects. Right. And this electron microscope is one of the practical applications of de Broglie's method. Okay, electron microscope is one of the practical application of Louis de Broglie's method. And it was based on the principle of wave nature of a moving electron. Okay, so what is the working principle of electron microscope? Wave nature of moving electron. Wave nature of a moving electron. Right. So principle of electron microscope is wave nature of moving electron. Wave nature of moving electron. Okay, so this is a basic principle of or working principle of electron microscope. Right. So it was first designed by Ernest Ruska. The first electron microscope was designed by Ernest Ruska, and its working principle is wave nature of a moving electron. So, electron microscope is a scientific instrument used in a research laboratory for the purpose of magnifying the small objects. Right. Here, the electron microscope is similar to the optical microscope. Which are optical microscope? Simple microscope and a common microscope, or commonly called as optical microscope. Okay, so electron microscope is almost similar to the optical microscope. It means the construction and the working of electron microscope is almost the same as the optical microscope. But few differences are there. What are the differences? So first one, in optical microscope, visible light or visible light is used to illuminate the object. Okay, in optical microscope, say simple microscope and a common microscope, visible light is used to illuminate the object. எந்த ஆப்ஜெக்ட் நம்ம மேக்னிஃபை பண்ணி பார்க்கணும்னு நினைக்கிறோமோ அந்த ஆப்ஜெக்ட் மேல எதை சார் illuminate பண்ணுவாங்க அப்படின்னா லைட், that is visible light. இதுல in optical microscope. Okay, in optical microscope, visible light is used to illuminate the object. Whereas in electron microscope, electron beam is used to illuminate the object. In optical microscope, visible light is used to illuminate the object, whereas in electron microscope, electron beam is used. Electron beam is used to illuminate the object. Right. And the second one, in optical microscope, optical lenses are used. Optical lenses means glass lenses. Glass lenses are used. Whereas in electron microscope, electromagnetic lenses are used. Electromagnetic lenses are used. Electromagnetic or electric lens or magnetic lenses are used in the case of electron microscope. Why? Because in optical microscope, the visible light can be focused or can be diverged with the help of optical lens. In optical microscope, the visible light can be deflected or can be focused with the help of optical lenses. But by using optical lenses, we can't focus or divert the electron because the electron beams are more energetic. So the electron beam is easily penetrate through the optical lens. So to deflect the electron beam, electric field or magnetic fields are used. So that is why in electron microscope, electromagnetic lenses are used. Okay, so electron beam can be deflected or can be focused either electric field or magnetic field. But by using ordinary lenses, we can't deflect or focus the electron. Right? So this is another difference between an optical microscope and the electron microscope. Okay, right. And third one, the maximum magnification. The maximum magnification that can be obtained in optical microscope is, already I told, 2000. The maximum magnification that can be obtained in optical microscope is 2000. Whereas the maximum magnification that can be obtained in electron microscope is more than 2 lakh. Why the magnification of electron microscope is much more than the optical microscope? Because its resolving power is very high when we compare it to the resolving power of optical microscope. Okay, what is the resolving power? What is the resolving power? Resolving power of a microscope is defined as the least distance between the 2 points which can be distinguished. The least distance between 2 points Students, students, hello.
Yes, sir.
Emma, இது வரையும் நான் பேசுறதெல்லாம் கேட்டுச்சா?
Yes,
Yes,
sir.
sir.
Okay, right. Right. The maximum magnification obtained in optical microscope is 2000, but in electron microscope, the maximum magnification is more than 2 lakh. Why? Because its resolving power is very high. The resolving power of electron microscope is very high than resolving power of optical microscope. Right? What is meant by resolving power? Resolving power of a microscope is the least distance between 2 points which can be distinguished. ரெண்டு பாயிண்ட் ரொம்ப க்ளோஸா இருக்கு, ரொம்ப க்ளோஸா எக்ஸிஸ்ட் ஆயிட்டு அந்த ரெண்டு பாயிண்ட் கூட பிரிச்சு பார்க்க முடியுது அப்படின்னா அந்த இன்ஸ்ட்ருமெண்ட், ஐ மீன் மைக்ரோஸ்கோப் இன்ஸ்ட்ருமெண்ட் உடைய ரிசால்விங் பவர் அதிகமா இருக்கு அப்படின்னா. Okay, so resolving power of a microscope is the least distance between 2 points which can be distinguished. Right. The resolving power of a microscope is mainly depends on wavelength of the light. So resolving power of a microscope is depends on wavelength. Right? We know the formula for a resolving power. Resolving power is equal to 2n sin beta divided by 1.22 lambda. So already we derived this equation and resolving power of the microscope in 7th chapter, wave optics. Am I right? Resolving power is equal to 2n sin beta divided by 1.22 lambda. Right? D minimum is equal to 1.22 lambda divided by 2n sin beta. The reciprocal of D minimum is nothing but resolving power. So resolving power is equal to reciprocal of D minimum, which is equal to 2n sin beta divided by 1.22 lambda. Right? Here n into sin beta is called numerical aperture. So 2 into Na divided by 1.22 lambda. The aperture of a given convex lens is constant. Here 2 and 1.22. So these are number. So resolving power is inversely proportional to wavelength. So resolving power of a microscope is limited by the wavelength of the light. Right? We know that in optical microscope, already I told, in optical microscope, visible light is used to illuminate the objects. You know what is the wavelength range of visible light? The wavelength range of visible light is from 4,000 Armstrong to 8,000 Armstrong, or 4 into 10 power minus 7 meter to 8 into 10 power minus 7 meter. So this is wavelength range of visible light, ordinary light, wavelength range is from 4 into 10 power minus 7 meter to 8 into 10 power minus 7 meter. So the wavelength of the light used in the optical microscope is of the order of 10 power minus 7 meter. 10 power minus 7 meter on the order level. Right. In electron microscope, electron beam is used to illuminate the object and the towards. When the electron beam is accelerated by applying a potential difference of 60,000 volts, the electron beam possesses de Broglie wavelengths. The de Broglie wavelength of the electron beam, when it is accelerated through a potential difference of 60,000 volt, is nearly 5 into 10 power minus 12 meter. Okay, if the electron beam is accelerated by a potential difference of 60,000 volt, the de Broglie wavelength of the electron becomes 5 into 10 power minus 12 meter. 5 into 10 power minus 12 meter, right? Now comparing the de Broglie wavelength of the electron with the wavelength of the visible light. So this is a 10 power minus 12 meter order, but the wavelength of the visible light is 10 power minus 7 meter order. So comparing these two, the de Broglie wavelength of the electron is nearly 10 power 5 times lesser than that of the wavelength of the visible light. Understand? The de Broglie wavelength of the electron beam, when it is accelerated through a potential difference of 60,000 volt, is nearly 1 lakh times, that is 10 power 5 times lesser than that of, or smaller than that of, the wavelength of the visible light. So the resolving power of electron microscope is 10 power 5 times more than that of the resolving power of optical microscope. Okay, if the resolving power of a microscope is more, the magnification value also more. If the resolving power of a microscope is less, definitely its magnification value also less. Right? Listen, in optical microscope, visible light is used. Its wavelength is of the order of 10 power minus 7 meter. In electron microscope, electron beam is used to illuminate the object. Its de Broglie wavelength is of the order of 10 power minus 12 meter. When if the electron beam is accelerated through a potential difference of 60,000 volts. So comparing these two wavelengths, the de Broglie wavelength of electron is nearly 10 power 5 times, lesser than that of the de Broglie wavelength of visible light. Right? We know the condition, the resolving power is inversely proportional to wavelength. If the de Broglie wavelength of the electron is 10 power 5 times lesser than that of the wavelength of the visible light, means the resolving power of electron microscope is 10 power 5 times greater than that of the resolving power of the optical microscope. So the electron microscope resolving power is more. If the resolving power more, what about magnification? The magnification value also more. So that is why I told the maximum magnification that can be attained in best optical microscope is 2000, whereas in electron microscope the maximum magnification is more than 2 lakh times. Why? Because its resolving power is more. Why the resolving power of electron microscope is more than optical microscope? The de Broglie wavelength of the electron beam used in the electron microscope is very much smaller than the wavelength of the visible light used in the optical microscope. Okay, right. Now we go for the construction and working of electron microscope. Already I told the working principle of electron microscope is wave nature of a moving electron. The wave nature of a moving electron. What is electron microscope? It is a scientific instrument used in the research laboratory for the purpose of magnifying the small objects. In electron microscope, electron beam is used to eliminate the object. When the electron beam is accelerated to a potential difference of 60,000 volts, its deep Brownian wavelength is 5 into 10 power minus 12 meter. 5 into 10 power minus 12 meter. Electron microscope is one of the practical application of de Broglie's matrix. Electron microscope is a practical application of de Broglie matrix. Its working principle is wave nature of moving electron. Wave nature of moving electron. Right now, we go for the construction and the working of electron microscope. And already I told, in optical microscope, the ordinary lenses are used to focus or to divert the visible light. But in electron microscope, the electron beam can be deflected or can be focused with the help of either electric field or magnetic field. So that is why the name of the lenses used in the electron microscope is electromagnetic lenses or some magnetic lenses. Mostly the magnetic fields are used in the electron microscope to deflect or focus the electron beam. So the lenses used in the electron microscope are commonly called as magnetic lenses. There are three types of magnetic lenses are used in the electron microscope, but they are condenser magnetic lens. Second one is objective magnetic lens, and the third one is a projective magnetic lens. Okay, so there are the three types of magnetic lenses are used in the electron microscope, but they are condenser magnetic lens, objective magnetic lens, and the third one is a projective magnetic lens. Projective magnetic lens. Right. Look at the diagram. Please all of you see the images of electron microscope. Right. Right. So these are some images of electron microscope. So images of electron microscope, and this is the images of the small object. The images of the small object given by electron microscope. Electron microscope. Right. Already I told the electron microscope consists of three magnetic lenses, namely condenser magnetic lens, objective magnetic lens, and projective magnetic lens. Projective magnetic lens. And also already I told the working and the construction of electron microscope is similar to that of optical microscope. In optical microscope, optical lenses are used. Optical lenses are used to magnify the small objects. Small object. Whereas in electron microscope, the magnetic lenses are used to magnify the small object. The three magnetic lenses are condenser magnetic lens, objective magnetic lens, and projective magnetic lens or projector magnetic lens. Projector magnetic lens. Right. And in electron microscope, there is a source of electron. Source of electron. In electron microscope, electron gun is acts as a source of electron. What is electron gun? Electron gun is nothing but an arrangement. It consists of a filament which is connected to a battery. The electron gun consists of a filament which is connected to a battery, and there is a cathode and anodes are kept along with the filament. Right. So this is controlled grid. Grid. This is controlled grid. So this is anode. So this arrangement looks like a gun, and it acts as a source of electron. So that is why it is called the electron gun. So in electron microscope, the electron gun acts as a source of electron. So this is a source of electron. Right. The electron is emitted from the electron gun by the process of thermionic emission. So when the low tension battery is connected to the filament, the electric current flows through the filament which heated up. So at one particular stage, the electrons are emitted from the filament. That process is called thermionic emission. Already know that. Okay, so by the process called thermionic emission, the electron beam is emitted from the electron gun. Right. Here, the electron beam is emitted from the electron gun. Right. The emitted electron is accelerated by the voltage of 60,000. Okay. When the battery is connected to the filament in the electron gun, the electric current eats up the filament. So due to the thermionic emission process, the electron beam is emitted, or electron beams are emitted from the filament. The emitted electron beam is accelerated by applying a potential difference of 60,000 volts. When the electron beam is accelerated through a potential difference of 60,000 volt, the de Broglie wavelength associated with the electron beam is 5 into 10 power minus 12 meter. Okay, so the electron beam from the electron gun is moving with the de Broglie wavelength of 5 into 10 power minus 12 meter when it is accelerated through a potential difference of 60,000 volts. Right. So those electron beam is made to fall on the first magnetic lens called condenser magnetic lens. Condenser magnetic lens. So one of the magnetic lens in the electron microscope is condenser magnetic lens. Condenser magnetic lens. Right. So the electron beam is emitted from the electron source. It is accelerated by the potential difference of 60,000 volts, so that its de Broglie wavelength is 5 into 10 power minus 12 meter. Such electron beam is made to follow the first magnetic lens called condenser magnetic lens. Condenser magnetic lens. So this condenser magnetic lens deflect the electron beam to form a parallel beam. The electron beam comes out from the electron source like this. When the electron beam is made to fall on a condenser magnetic lens, this lens deflects the electron beam to form a parallel beam. Okay, right. And this parallel beam is made to fall on the object to be magnified. அத எந்த ஸ்மால் ஆப்ஜெக்ட்டை நம்ம மேக்னிஃபை பண்ணி பார்க்கணும்னு நினைக்கிறோமோ அந்த ஆப்ஜெக்ட் மேல இந்த கண்டென்சர் மேக்னெட்டிக் லென்சஸ்ல இருந்து வர அந்த parallel electron beam கொண்டு போய் ஃபோக்கஸ். Okay, the parallel electron beam from the condenser lens, okay, passing out from the condenser lens is made to fall on the object to be magnified. The object to be magnified. Right. When the electron beam is made to fall on the object to be magnified, only a part of the electron beam is passes through the object or comes out from the object. So remaining electron beam may be absorbed by the object itself, and some part may be reflected by the object. Okay, like that. So only a few part of the electron beam comes out from the object to be magnified. Right. So the electron beam which comes out from the object have or bring the image of an object. Okay, so those electrons are called transmission electron or a transmitted electron beam. Transmitted electron beam. The transmitted electron beam will carry the image of an object. And the electron beam object la irundhu velila varumbodhu and the image carry and object image carry panni. Okay, right? The electron beam from which is passing through the condenser magnetic lens is made to fall on the object to be magnified. Only a part of the electron beam comes out from it, which bring the images of an object. To bring the image of an object. Right. And the name of the electron beam comes out from the object is called a transmitted electron beam. Transmitted electron beam. Right. That transmitted electron beam is made to pass through another magnetic lens is called objective magnetic lens. Objective magnetic lens. So why this magnetic lens is called objective magnetic lens? Because this lens is kept near the object. If any lens which is kept near the object, then the lens is called objective lens. Here magnetic lenses are used in electron microscope. So that is why the name of the second magnetic lens is objective magnetic lens. Objective magnetic lens. Right. When the transmitted electron beam from the object is made to fall on the objective lens, this lens diverge the electron beam and to produce the enlarged image of the object. So this is enlarged image. This is enlarged image. Okay, the transmitted electron beam from the object is made to pass through the second magnetic lens is called the objective magnetic lens. It diverges the electron beam and to form the enlarged image of the object. The enlarged image of the object. Right. Finally, the electron beam is made to focus on the fluorescent screen or photographic plate with the help of the third magnetic lens is called the projector magnetic lens with the greater magnification. Okay, இங்கிருந்து வர இந்த எலக்ட்ரான் பீம் அதாவது அப்ஜெக்டிவ் லென்ஸ்ல இருந்து வர அந்த எலக்ட்ரான் பீம் ஃபைனலா எங்க கொண்டு போய் ஃபோக்கஸ் பண்ணும் அப்படினா on the photographic lens or on the fluorescent screen with the help of the third magnetic lens is called projector magnetic lens. lens. அது மேல கொண்டு போய் எது மேல ப்ரொஜெக்ட் பண்ணுவோம்? ஸ்கிரீன் மேல. எதை யூஸ் பண்ணி? தேர்ட் மேக்னெட்டிக் லென்ஸ். அதனால அந்த தேர்ட் லென்ஸ் ப்ரொஜெக்டர் மேக்னெட்டிக் லென்ஸ். So with the help of projector magnetic lens, finally the electron beam is focused on the screen for a direct view or focused on the photographic plate for the permanent record. அந்த இமேஜ் எப்பவுமே பெர்மனன்ட்டா நம்ம ரெக்கார்ட் பண்ணி வச்சுக்கணும் அப்படின்னா photographic plate யூஸ் பண்ணிக்கலாம். பட் அந்த டைம்ல மட்டும் நம்ம இமேஜ் விஷுவலா பார்க்கணும் அப்படின்னா photographic plate பதிலா ஒரு fluorescent screen யூஸ் பண்ணிக்கலாம். So for a direct view, fluorescent screen is used in the electron microscope. For permanent record, instead of fluorescent screen, photographic plate is used. So the final image is formed on the photographic plate with the help of projector magnetic lens. Projector magnetic lens with greater magnification. இந்த இடத்துல இந்த மேக்னிஃபிகேஷனை விட இன்னும் அதிகமா மேக்னிஃபை பண்ணி இந்த photographic plate மேல கொண்டு ஃபார்ம். Okay, so once again I repeat, there is an electron source which emits electron beam by the process of thermionic emission. Those electrons are accelerated by a potential difference of 60,000 volts. So to possess the de Broglie wavelength of the order of 5 × 10⁻12 meter. And those electrons are made to pass through the first magnetic lens is called a condenser magnetic lens. This magnetic lens deflects the electron beam to form a parallel beam. Diverge ஆயிட்டு வர அந்த electron beam deflect பண்ணி parallel beam மாத்துறதா இந்த condenser magnetic lens உடைய யூஸ். Right. And this electron beam is made to fall on the object to be magnified. எந்த ஆப்ஜெக்ட்டை மேக்னிஃபை பண்ணி பார்க்கணும்னு நினைக்கிறோமோ அது மேல அந்த parallel beam கொண்டு போய் ஃபோக்கஸ் பண்ணிடும். Right. Then what will happen? Only a part of the electron beam is transmitted to the object. So that is why those electrons are called transmitted electron or transmitted electron beam. Transmitted electron beam. Right. The transmitted electron beam bring the image of the object. இந்த ஆப்ஜெக்ட் உடைய இமேஜ் அந்த வெளியில வர எலக்ட்ரான் என்ன பண்ணும்? எடுத்துட்டு வரும். Right. If the transmitted electron beam from the object is made to fall on the second magnetic lens is called objective magnetic lens, which diverge the electron beam to form the enlarged image of an object. இப்போ அந்த ஆப்ஜெக்ட்ல இருந்து வரக்கூடிய அந்த டிரான்ஸ்மிட்டட் எலக்ட்ரான் பீம் இந்த ஆப்ஜெக்டிவ் லென்ஸ் டைவர்ஜ் பண்ணி உனக்கு என்லார்ஜ் இமேஜ் ப்ரொடியூஸ் பண்ணலாம். Right. Finally, the transmitted electron beam is made to focus on the photographic plate or otherwise fluorescent screen with the help of a third magnetic lens called projector magnetic lens. Okay, with the greater magnification. இதை விட இன்னும் அதிகமா மேக்னிஃபை பண்ணி இந்த photographic plate மேல ஃபார்ம். Right. So this is construction and working of electron microscope. The construction and the working of a microscope is almost similar to the top, the construction and the working of optical microscope. Okay, the only differences is that in optical microscope, the visible light is used. In electron microscope, the electron beam is used. In optical microscope, ordinary glass lenses are used to focus or deflect the visible light, but in electron microscope, magnetic lenses are used to deflect or focus the electron beam. The maximum magnification that can be happening in optical microscope is 2000 only. But in electron microscope, the maximum magnification attained is more than 2 lakhs times. Reason? The resolving power of electron microscope is more. Why the resolving power of electron microscope is more than the resolving power of ordinary optical microscope? Because in electron microscope, the electron beam de Broglie wavelength is of the order of 10⁻12 meter. But the visible light wavelength which is used in the optical microscope is of the order of 10⁻7 meter. So comparing these two wavelengths, the de Broglie wavelength of the electron beam is a nearly 1 lakh times smaller or lesser than that of the wavelength of the visible light. What is the relation between resolving power of a microscope and the wavelength of the radiation used? Inversely proportional. If the wavelength is lesser, resolving power becomes greater. So, the broad wavelength of the electron beam is much lesser than that of the wavelength of the visible light. So, the resolving power of electron microscope is much more than the resolving power of optical microscope. If the resolving power of the microscope is more, the magnification produced by the microscope also more. If the resolving power less, the magnification also less. So that is why the electron microscope magnification is more than 2 lakhs. There are 3 types of magnetic lenses are used in the electron microscope, but they are condenser magnetic lens. What is the use of condenser magnetic lens? To deflect the electron beam from the electron source to form a parallel beam. Electron source la varakuriya electron beam deflect panni parallel beam maati adha object mele podu focus pandratha first lens use. What is the name of the first lens? Condenser magnetic lens. Right. And second magnetic lens is objective magnetic lens. What is the use of objective magnetic lens? The objective magnetic lens is used to deflect the transmitted electron beam from the object to produce enlarged image. Object la irundhu varakuriya the transmitted electron beam deflect panni periya oru image produce panni kudukkradha second lens use. Right. And the third magnetic lens is called projector magnetic lens. What is the use of a projector magnetic lens? The projector magnetic lens is used to focus the electron beam on the fluorescent screen or on the photographic image with a greater magnification. Okay, on the image magnify பண்ணி ஒரு ஸ்கிரீன் மேலயோ இல்ல ஒரு photographic plate மேலயோ கொண்டு போய் focus பண்றது project பண்றதுக்கு இந்த lens யூஸ் ஆகும். So that is what is called projector magnetic lens. Projector magnetic lens. Right. So this electron microscope is almost used in all branches of science. All branches of science. Physics department use of chemistry department, biology department. So it is used in all branches of science. So this is the images of the small objects. Okay, சின்ன ஆப்ஜெக்ட் நம்ம ஒரு எலக்ட்ரான் மைக்ரோஸ்கோப் யூஸ் பண்ணி பார்த்தோம் அப்படின்னா அந்த இமேஜஸ் உனக்கு இப்படி தெரியும். So these are some images of the object obtained from electron microscope. Right? Okay, students. Electron microscope is over. Shall I ask some questions?
Yes, sir.
Right. What is electron microscope and what is its use?
Scientific instrument which is used
It is the scientific instrument used in
for magnifying the small object.
Very good. It is a scientific instrument used to magnify the small objects. Right. What is the working principle of electron microscope? Hello? What is the working principle of electron microscope?
Wave nature of electrons.
Wave
nature of moving electron.
Very good. The wave nature of a moving electron. Right. Can you say what are the 3 types of magnetic lenses used in the electron microscope?
Condenser lens,
magnification lens, objective lens,
projector
lens.
Right. Condenser magnetic lens, objective magnetic lens, and the projective magnetic lens. Right. What is the value of the maximum magnification that can be applied from electron microscope?
more than 2
More
lakh.
than 2 lakh.
Very good. More than 2 lakh. But the maximum magnification that can be obtained from optical microscope is
2000.
2000.
2000. Right? Is any doubt on this topic?
No, sir.
No, sir.
Right. Okay. Okay.
No, sir.
Thanks.
ஏடா இப்ப நிமிஷம் முடிக்கிட்டு ஒரு நாள் வச்சடா
Morning, Glenn. Morning. Twelfth chemistry. We are going to study about what are called silicates. We have already studied about what are called as silicates. And here the silicates are nothing but that it is to be based on the structures, that is SiO2. This is nothing but we have studied as silica. In that silica, thus it can produce, the silica can produce many compounds like mica, parts, all are the important materials for the purpose of manufacturing asbestos, glass, and everything. So it is the raw material for there is manufacturing of glass. You know that this is a major glass material, glass and mica. These are all the important parts. These are all the important materials for this modern world. So next we are going to study about. Here there are many kinds of the silicates. Today we are going to study about double chain silicates. Double chain silicates. Or nothing but happy balls. These silicates containing these silicates containing there is a sign 4 O11, that is 6n minus. This is the charge. Sometimes you know that a sign O4 4 minus we are saying. This is a charge. That means that is Sc, that it is carrying charge. This metal is joined with this silicon tetrahedral structures. That is the sign O minus. This is sign O4, sign O4. Charge is 4 minus. This is the meaning. And here, in these silicates, there are two different types of tetrahedrons. In this structure, in these structures, Hi students. Dear students.
Sir.
Okay. Now, these silicates are, that means happy balls silicates. Happy ball silicates or nothing but double chain silicates. This double chain silicates are nothing but, in this silicates there are two different types of tetrahedrons. In these silicates there are two types of tetrahedron. What are the two types? That means there is 3 vertices, 2 vertices. What is meaning of the vertices? Means there is 3 oxygen is linked together in some cases. In some cases, 3 oxygens are linked together and the 2 oxygens are linked together. If there is a 3 oxygen is linking, that is 3 vertices, 3-dimensional structure. If 2 oxygen is linking, that is 2 vertices, that is 3-dimensional structures. The point you should understand here. The next things, you please understand here, the next thing. The example for this structure is aspartate sheets. So what is the structure of this aspartate sheets? The structure of aspartate sheet is the aspartate sheet. You know that the example for this amphiboles is there is aspartate sheet. Example for this type is aspartate sheets. Aspartate sheet. What is the structure of this aspartate sheet? Structure, chemical structure. The chemical structure of aspartate sheet is, you are coming to know the point here. There is a point you should here. You see, in this case of aspartate sheet. Here there is a point oxygen, O minus. Here silicon. Over the silicon, oxygen. Next the point you can write here that oxygen. Here the oxygen. Actually, this is the tetrahedron structure. You please understand the point here, tetrahedron. Silicon over the oxygen here. Si is metal is bonded, that is rear side. Now it is O minus, O minus, O minus. Here one oxygen, O minus. Now another structures. We come to know the point here. There is that oxygen. The point is here. There is that oxygen, and here oxygen, here oxygen, here oxygen. Now in these cases, there is one oxygen with that silicon is bonded over oxygen. This is also the tetrahedron. This is structure. Next to here the oxygen, here the silicon, and over the silicon there is oxygen, O minus, O minus, O minus, there is a bond. There is a bond you can write here. Structures. Next the point here. Next structure we are coming to know. There is a tetrahedron, silicon bonded over the oxygen, O minus. There is oxygen. Here the tetrahedrons. Here also there is a bond. Oxygen here, silicon here, bonded over oxygen. There is that O minus. So this is a structure. That is also you see here. There is a structure, oxygen. Here the point you can write. Now you see O minus. Here also the point oxygen here. over this oxygen here there is a point with that SI. It's a structure of that silicates. It's going on the structures. Going on the structures. Now you can go for this tetrahedral. That you see here, here may be the oxygen. Here to 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 be the oxygen. Here there is a SI. Over the oxygen. O. Here there is oxygen. SI. Here over the oxygen. Here oxygen. Here oxygen. There is a bond. Here over the oxygen. Here SI over the oxygen. Bond. Here the point. Here that oxygen. SI over the oxygen. The structure is going on. Now this is. There is oxygen. Going on the structures. This is nothing but we can say Hampible's structures of the silicates. Next, we are going to study about seed or phyllosilicates. Seed silicates or phyllosilicates. Seed silicates. Seed silicates or phyllosilicates or phyllo. Next point we are going to see here the silicates which containing these types of silicates. Which containing Si2O5, Si2O5, there is N to the power of 2N minus. This is the charge. This is a charge. 2 minus. Now this is the number of units, three-dimensional units. Number of units. N says about number of units. In this case, the structures which containing is SiO4 4 minus. SiO4 4 minus. SiO4 4 minus. SiO4 4 minus. Tetrahedron units are present in these structures. Each tetrahedron unit shares 3 oxygen atoms by other units. In this structure, all the 3 oxygen atoms are sharing. That you see here for this is oxygen O minus, Si O minus. Here the structures we are coming to know. Tetrahedron. This is O minus, O minus, O minus. Now the point here. This is tetrahedron. This is Si. You see here Si. This is O 4 minus. This is shortly written as this form. Si O minus, O minus, O minus, O minus. That is the point of the structures. These tetrahedrons are linked by this. All 3 oxygen is undergoing linking. 3 oxygens are undergoing linking. That is, in this structure, 3 oxygen atoms are linking with another unit. Point you should understand how this linking takes place. Now, you please take here these structures, and here the sharing 3 oxygen atoms in these other units by forming 2-dimensional structures. By forming two-dimensional structure. Two-dimensional structure. Two-dimensional structure. By forming two-dimensional structure. Now we are having this structure. These sheets of silicates are layered structure in these silicate sheets. Stacked over this another. One is stacked over another one. One is stacked over another one. The attractive forces are very less. So this is can easily claiming the structure for these silicates are we are going to study about how these structures we can elucidate the structural elucidation of these silicates. This is to be the point you can understand the structural elucidations. The structural elucidations. The structural elucidations. That you see here, for example, oxen. And here in this case, there is an oxen, there is silicon over the oxen. That you see here O minus here. 4, that you see S sign 1, O 4. The charge is 4 minus. In each and every space, we could understand this point here. In each and every places. That you see here also O minus. There is a sign over the bond. Here also O minus. That you see here also there is O minus. You see the point here O minus. And here O minus. The structures we could write here over the sign over the oxen structure. Here also there is O minus, the structure. Here also there is O minus, a sign over the oxen, O minus, the point. Here also there is the point. Here also there is a point. The sign. Here also there is O minus. A sign over the O minus. Here also O. A sign over the O minus. O. A sign over the O minus. This is going on the structures. And here we coming to know the point here. There is also hexagonal. There is also hexagonal. There is also a hexagonal. This is going on these hexagonal structures. One sheet over this another. One sheet over this another. One sheet over the another. This is the point you should understand. It's going on in structures. This is that the structures of sheet or phytosilicates. This is that structures or sheet silicates or phyllosilicates. Sheet structures or phyllosilicates. The point you should write here, the sheet or phyllosilicates. And here, this one layer, this is one layer, this is one layer, and this is one another layer. These layers, there is a attractive forces between these two layers. The attractive forces between these two layers. Attractive forces between these two layers are very weak, so that it can claim, the structures are undergoing breaking. It's nothing but the forces are very less or very less, so that it can undergo cleavage, clave. And that is a point we should understand easily, just like as graphite. It's a point you should understand here. Next, the example for this all, or example for this all, or talcum powder, that is TiAl mica, or the example for these structures. Next, we are going to study about three-dimensional silicates, tactosilicates. Three-dimensional silicates or tactosilicates. Three-dimensional silicates. Three-dimensional silicates. Three-dimensional silicates, or it is tactosilicates. 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 The three-dimensional silicates or tactosilicates, also the silicates, is also having this tetrahedron. Tetrahedron, that is SiO4 4 minus. SiO4 4 minus. The point is, tactosilicates also having the same tetrahedron structure. And here the tetrahedrons form three-dimensional networks are called three-dimensional silicates. This SiO4 4 minus is, even though it is tetrahedron, but these tetrahedrons are to be framed, three-dimensional framework. Three-dimensional framework. Network. Three-dimensional network. Three-dimensional network. The point you should understand here, three-dimensional networks are to be involving in these structures, tactosilicates, but which is having general formula for tactosilicates. General formula for tactosilicate is a SiO2. A SiO2, that is N times. Is that general formula? Example for this tactosilicate is fats. Example for this type is fats. Fats is the example for this type of silicates. But these tactosilicates can be converted into three-dimensional. These tactosilicates are converted into. These tactosilicates are converted into three-dimensional silicates. Three-dimensional silicates. By changing three-dimensional silicates, by replacing this point, you should understand the tetrahedron SiO4 4 minus is changed over. Changed. This position is changed by the. This is changed by the ALO5. AlO4 5 minus. The C, it is aluminosilicates. Aluminosilicates. The structure, you please understand aluminosilicates. The aluminosilicates. In this tetrahedral structures, Si O minus, O minus, O minus, O minus. This position has been changed by this unit of Al. By this unit of Al. This structure is completely changed. The position of silicon is to be taken over by the position of aluminum. This position of silicon is taken over by this aluminum. Now it is nothing but we can say aluminum silicate. After this, change over these structures. Example for this structure is this is the example we are going to study about. Example. What are the example for tactosilicates? The best example for the tactosilicate is zeolite and feldspar. Feldspar and zeolite. The zeolite is a very important silicate. Very important silicates. It is the field of hardening of waters. In the field of hardening of water. Hardening of water. So this is a very important science. Just purifications. It is used in the purification of water. Purification of water. Please understand. Next to that, how this zeolite is to be working. How this zeolite is working. Zeolite is also having three-dimensional crystalline structure. Zeolite is a three-dimensional structure. It is in a three-dimensional structure. Zeolite is in a three-dimensional structure, and it is also having zeolite is also having the structure of zeolite or the three-dimensional structure, which containing zeolite, which containing silicon, aluminum, and silicon and oxygen. These are all the three important elements that are to be regularly arranged as in this three-dimensional network. As in the three-dimensional network. And here it is that they are hydrated by sodium aluminosilicates. Zeolite is, which is named as hydrated. This absorbed water is hydrated. They are the hydrated sodium, aluminium, sodium, alumino silicates. Zeolites are otherwise known as, it is hydrated sodium aluminum silicates. The zeolites are otherwise known as sodium aluminum, and which is having the general formula of, that is NaO dot Al2O3 dot XSiO2 dot YH2O. That X molecules of, that is X is equal to 2 to 10 molecules of 2 to 10 molecules of 2 to 10 And here that y is equal to that is 2 to 6 units of water. Units of water. Here 2 to 10 units of SiO2. The point you should understand. Next the concept we are going to study about the zeolites. All are having a porous, you know that porous unit. Porous unit. Porous unit. You know that what is the meaning of porous? The zeolites are having, and here it is which are all to be monovalent. The monovalent anions and water molecules are loosely held. Here in this zeolite is having porous unit. In this porous unit, the monovalent Na plus ions and water molecules and here the water molecules are loosely held and that means here in these structures we have seen there is NaO is also there, SiO2 is also there, and also H2O is also there. In this this zeolite section there is an Na, sodium. This sodium is having monovalent, that means Na plus ions. And these Na plus ions are also containing water, that is 2 to 6 molecules of H2O is to be present here. And here water molecules are present. So these all water molecules are associated with the sodium ions. The point is, you should understand here. And these all to be loosely held. And here that aluminium and silicon, the point is very important. The aluminium and silicon, these all to be tetrahedrally bonded. Tetrahedrally bonded with each other. Tetrahedrally bonded to these all two items. These all two items are tetrahedrally bonded. Here in this tetrahedrally bond, there is all tetrahedrally coordinated with this all aluminum and silicon. These two are bonded by oxygen atom. The point is, this is coordinated by oxygen atom. These two are coordinated by oxygen atom. These two items are coordinated by oxygen atom. There is a zeolite are similar to the clay particles. Zeolites are similar to clay. Zeolites are similar to clay particles. You know the clay, mud. So the point you should understand here, there is a next concept we are going to study about. So the zeolites are similar to these, and before they are a crystalline structure, but clay and zeolite are differ in these structures. That zeolite is as like as clay, but these two are differ. These two are differ in structures. But atoms are same, but the structures are different in these crystalline structures. The crystalline structures are different. Crystalline structures. This is also to be crystalline. These two crystalline structures are different. The point you should understand here. Next, what are the structural identity for zeolite?
structural identity for zeolite, that it is to be three-dimensional structure. That it is to be three-dimensional structure, and also which is having the point honeycomb structure. This all we studied in 11th standard, honeycomb structure, and which are also three interconnected. The interconnected tunnels and couch structures, tunnels and a couch structures. And here the water molecules which are containing inside this water molecules are containing the zeolite, that is 226, H2O is present in zeolite in crystalline structure. These water molecules are move freely, and here in these zeolite structures there should be a porous in it. Porous, that means which is allowing, which is permitting. This is to be the zeolite, and here there is that screen which is made up of zeolite. Please understand the point here. And here you are taking water here. You supposed to be. This is an example. Here is full of water. This water can pass through into the zeolite because it is porous. This water can come outside. Here, this is to be impure water. But here, coming out from the zeolite is pure water. That is, you are using harness of water, harnessing, removing of impurities. Like this is that water molecules are freely moving. H2O molecules are freely moving in these zeolites. The point you should understand here. Then the point there is which is having this these crystals act as a molecular seal. These crystals act as molecular sealing. There it is. We can separate the molecules. Big molecules and small molecules are present here. Now you take this zeolite, and here we can see, that means we can separate out the molecules. That is, we can use it as a molecular sealing, and also which is used for the permanent hardness of water. Which is also used for the permanent hardness of water. Which is also used for permanent hardness of water. The point is, and also it is used for, and the suppose why it is to be used as a molecular sealing, because molecules are separated because the porous size is similar in all cases. That's why we can able to separate the molecules. That's a point you should understand here. Next, we are going to study about the concept what is related to the next point. What is related as the concept is next to there is that one of the point which is been argued book is the boron, neuron, capture-trophy. These all elements, and here the 13 group, 14 group. Now we have studied about the 14 group elements. This all we have completed. Next, we are going to study about the boron, neuron, capture-trophy. Boron is used in neuron. Neuron. That is, boron is used in neutron capture therapy. Please understand what is boron is capturing neutron. You know that neutrons. There is a subatomic particles, protons, electrons, neutrons. No charge. That is in nuclear chemistry, we are using N0. No charge. That's a point you can write. Proton is positively charged. Electron is negatively charged. This is the boron neutron capture therapy we are using. And what's the name of the boron which is used, isotopes of boron used for this therapy? And the affinity of boron 10, B10, boron 10 is used for this. There is neutrons is in this basis of techniques, that is neutron capture therapy. This is shortly we can represent it as boron neutron capture therapy, BNCT. And here boron is to be used for the patient who are suffering from the brain tumors. Not only the brain tumors, this we are using for the cases of the disease, namely the tumors are to be present in the head, neck and breast, head, neck and prostate. And here the phase of prostate glands, prostate glands, and here in that is in liver and the liver. If there is any tumors are present in head or neck or breast or prostate or the liver, these are all the very critical places. We cannot remove the tumors, that is like cancer. So these tumors are removed by passing boron 10 in our body. So this boron to be, if it is that there is a tumors in brain, if there is a tumors in brain, this is a tumors, we ought to pass this boron 10 into the body immediately. This tumors is to be completely eradicated, completely is to be removed by this boron 10 by producing that neutrons. The point you should understand here. The boron compounds are injected in our patient, Boron is injected. Boron 10 is injected in the body. Injected into the human body. And here it is the compound is collected perfectly in the tumors. The tumor areas, then it is irradiated. There should be any radiations. There should be any radiations irradiated around the tumors. If there is a tumors, this all radiation will take place around the tumors. And here this tumor is irradiated. The tumors are completely removed. By this causing this boron 10. The result in this and releases the alpha particles. that during this radiation, there should be alpha particles. There should be alpha particles. And here these alpha particles that damages the tissues in the tumors each time a boron 10 nucleus capture the neutrons. That you see, the boron 10 is capture the neutrons by the passing alpha particles. Alpha particle is to be releases the alpha particles that the damages of the tissues and the tumors in each and every time in this boron 10 nucleus capture the neutron. In this way, the damage can be limited and preferentially to the tumors, and the living normal brain tissues is less affected. So while we are doing this radiation, the normal tissues around these tumors is not affected. Only the tumors are completely needs to be replaced by these radiation methods. So just boron 10 is passed into our body, injected into our body. So this is that there is a radioactivity reaction which is taking place inside in our body to how to cure the cancer. This is like a cancer therapy. The boron neutron that is capture therapy. Boron is captured during this alpha particle which releases the boron, that is a neutron, and these neutrons are captured by this boron, and while it is capturing this boron, there is a neutron by the boron. What will happen? This boron is acting against and reacting against to the tumors. While it is against to the tumors because of the radiation, and here the tissues which are around which are near to these tumors is not affected. It is the best methods for this. There is to be cancer therapy. This is boron, neutron, cancer therapy. This is a point we should understand here. And this is one of the important uses for the cases of there is P block elements. Generally, P block elements are very important that the next two P block elements which we are going to study about these. That is the point we should understand. P block 2. That's the point we are going to study about. On this next session, you please understand the children. Next session, we are going to see what is the P block elements. That is the next two P block elements. That is P block elements 2. This P block elements 2 is nothing but we can study it as P block elements 2. We can study it as that is to be the first time it is given our book is 15th group elements. Group elements. What are the 15 group elements? That the boron, here the P block elements are nothing but boron family, carbon family, nitrogen family, oxygen family. These are all that concept, that halogen family. This is we have studied. Boron 13, 14, 15, 16, 17. That is halogen family. That is 18th. That here the fluorine is the first element. That here that neon is the helium neon is the first element. So this is nothing but boron family, carbon family, nitrogen family, oxygen family. This is chalcogen family. This is halogen family. This is a point you should know. In this boron family we completed. Carbon family we completed. Next we are going to study about 15th group element is called nitrogen family. In this nitrogen family, we are going to study about what are the elements that are belonging to this nitrogen family. Nitrogen family, what are the elements? That the first element is nitrogen, phosphorus, arsenic, antimony, bismuth. And here the nitrogen and its atomic number is 7, mass number is 14. and its phosphorus and its atomic number is 50, Mohs number is 31. And here arsenic, the atomic number is 33, and whose Mohs number is 74.595, so it is 75. And here antimony, and whose atomic number is 51, whose Mohs number is 121.76 is 22. We can take it as. And next we are going to study about bismuth, whose atomic number is 83, whose Mohs number is 210. This is a point you can write here. So this is the families of this nitrogen and its elements. Now we are going to study about what is the electronic configuration, that you know. The electronic configuration of these all elements we can written as this form. That is helium core element, neon is the core element, helium, neon, argon is the core element, and here helium, neon, argon, krypton is the core element. Here it is that xenon is the core element here. The point you should understand. And apart from this, we are going to write about this electronic configuration. Helium, without helium, and 2s2, 2p5 is its 2p3 is its electronic configuration. Why? Because 5 is the valence level electrons. 5 is the valence level electron. In all cases, generally that ends with that is see your neon, that is 3s2, 3p3. That is a 5 electrons. Even next we can go for argon, that is 3d10, it's a core, it is inner. But here it is 4s2, replace 4p3. In next to that, we are coming to know there is krypton and 4d10 and 5s2 and 5p3. And here it is that last one, 4f14. The point you should understand. And here it is 5d10 and here 6s2, 6p3. Now you see here in all cases there is a 5 electron in each valence level. You see in all cases 2s2, 2p3, 3s2, 3p3, 4s2, 4p3, 5s2, 5p3, 6s2, 6p3. This is the general electronic configuration for these all elements. But here we are going to study about majorly the nitrogen and phosphorus. The nitrogen which is occurring in terrestrial occurrence and in atmosphere. 78% of that nitrogen which is present in atmosphere as it is form of nitrogen gas, N2 gas. N2 gas. Time achila? Sir, time achila? Okay, sir. So children, tomorrow we are going to continue this nitrogen family chapters. Right, we are going to see here in this on next session. Thank you. You please understand about what is liquids,